I'm going to go through the data collection and analysis for a cart down an incline. And my video came out upside down, which will happen to you at some point. It's again not a big deal. We're just going to work with it upside down because it makes no difference in our overall results. So as the first thing that I do once I've imported this information is I'm going to fast forward until I can see that my hands are just off of the cart, right? So I'm going to go forward a bit, go forward, right? It's going to, oops, I can go back right there. Okay, so that's where I'm going to start. So I'm going to bring my origin to the front of the cart, this front corner, and then I want to tilt this axis so that it's parallel to the direction of motion. I'm moving in the positive direction here, and then I need to use the meter stick, so I'm going to start here 0. Don't forget I'm upside down, so I can see that this is 20, 30, 40. So you can put any distance you want. I can't see the end because my hands are in the way, but I can go up to 90. So that's what I'm going to do. I'm going to be as careful as possible. And then I have to change this. It's much better to leave this in meters than to convert it. I don't know why it makes Capstone a little cranky. If you want to hide these things, that's fine, but make sure you turn them back on before you take a screenshot of your tracking because I want to be able to see them. Remember, put on your magnifying glass so you can see this easily and pick a point on your car and click and click. And we're just going to go through. Make sure you always click on the same point. Try to be as careful as possible. This won't take as long as the other one because it's going to get faster and faster, so you're going to actually get to move the cursor right over. And it gets a little blurry, that's okay, and you can go past the end of the meter stick, right? You're going to go until you reach the end of your ramp. You're going to have an end stop, so I'm going to stop here because then it goes off the ramp. So I've got my tracking. I'm going to turn my axis and my calibration tool on. I'm going to screenshot this because this is my data. You have to include your data. You don't need all this. So I'm going to take a narrow picture. All right, so now I've got that. So on our x-axis, we're going to show position versus time, but I'm moving on the x position, so I want to make sure I show that x position. And on this axis, we put time. And we should be able to put a nice quadratic fit on this. Delete the legend because there's only one line, and condense this so that it's not spread out so much. And if you control click on this box, you can uncheck uncertainty and you get this nice quadratic fit. This RMSE value is the inverse of the R squared value. To find the R squared value from this, you're going to subtract from 1. So let me show you what that looks like. I'm going to put in my text box and I'm going to write out the ax squared plus bx plus c. This is a quadratic fit. We could have done a power fit. So let me take a second to talk about this. Look at all these different fits. We're never going to use all these. We could do a power fit, but it's much more complicated and you'll get the very similar results. How do you know? Well, we're going to have to talk about that a little bit more when we talk about graphing in this unit. But for now, let's just take my word for it that it's a quadratic fit. So let's put in the values that I have for my A. Put in the values for A, for B, and for C. The RMSE value is 0.0172. Therefore, my R squared, the R squared value is 1 minus 0.0172, which is 0.9828. So now that's how you figure that out. Can I? Okay, so then you can take a screenshot of your graph. Let's make this nice and big so you can see the whole thing. So I'm going to take this screenshot and I'm going to copy and paste this part into my lab report and fix the formatting, right? You want this to be squared. I can't do it on here, but you can do it on your document instead.